and welcome to the fifth episode of the MDSI-Vaani podcast series of interviews, an engaging and novel initiative of the Movement Disorders Society of India, centered on bringing to light groundbreaking research work in the field of movement disorders in the country. Every month, we get in conversation with researchers and authors of landmark studies and papers, and today we will be delving into a recently published first of its kind study on a potentially new adjuvant therapy for a growing epidemic, none other than Parkinson's disease. Before I start with introductions, greetings to everyone tuning in from different places and various time zones. I am Dr. Tripthi Sugumar, currently a movement disorders fellow at the University of Alberta, Canada, and also assistant professor neurology at the Sri Ramachandra Institute of Higher Education Research, Chennai. And I hope you all are as excited as I am today to have as our guest speaker for this episode, a physician par excellence, avid researcher and administrator, none other than the secretary of the MDSI himself, Dr. Hrishikesh Kumar. Now, Dr. Kumar needs very little introduction, but for the benefit of those who don't know, he is the director of the Movement Disorders and DBS program, head of Department of Neurology, director and the Jaswandi Sud Chair of Movement Disorder Research, and also vice chairman at the Institute of Neurosciences in Calcutta. He's also a member of the Education Committee of the International Parkinsons and Movement Disorder Society, the Asia-Oceanic section, and also chief editor of the Movement Disorders in Clinical Practice journal, the Indian edition. He is currently leading a host of research projects and has in fact received grants just this past year for 3 clinical trials and a grant from the Indian Academy of Neurology Research Grant Scheme for a project very similar to the published study that we are going to be discussing today. On a personal note, he loves all things fitness and travel, loves to hike, and is constantly encouraging me to pursue and make use of all the experiences that Canada has to offer, having lived and done his fellowship there here many years ago himself. So a very warm welcome to you, Dr. Hrishikesh. It is such a pleasure to be able to do this with you today.
Thank you.
Thank you for being here.
Thank you very much.
So before we talk about today's paper for discussion, I must ask you, sir, how were you able to build a robust research program in essentially a private hospital in India, that too?
Yeah, that's a good question. When I plan to come back to India after fellowship in Canada, it is very clear that I won't be satisfied by only clinical practice, and I have to have research focus. And when I joined this Institute of Neuroscience in Kolkata, which is a private institute, I told the CMD, which is none other than Professor Robinson Gupta. He is a neurosurgeon par excellence, and he is known all over the world, that if you are taking me, you have to give time, you have to give space, you have to give some funding to start a research place. And he agreed to that. What happens when you come back with research focus? It's very easy to get swamped in the clinical practice in India. In 1 or 2 years, there's so many patients that you start losing focus. And that way, I'm happy that I have a good bunch of researchers, good bunch of fellows who have stimulated me. And every day, at least 1 hour spent in the lab to guide them, to talk to them, to learn from them. And that I have continued. Whatever be the clinical scenario, whatever be the clinical load, I keep on doing that. And due course of time, I got some private funding from some friends, from some patients also, and that helped me quite a lot. We got a proper PhD program going on with the help of Calcutta University. So things kept on adding, and I'm lucky that this has survived and this has thrived till now.
And that's how you're sustaining your lab.
Exactly.
That is truly commendable. I mean, research is always confined to major institutes like, AIIMS and NIMHANS, etc. And, in India per se, like you said, it's very not exactly easy to implement. So it's amazing the work that you're doing and the support that you have.
Thank you.
So let's go straight into today's paper. Today's paper and study for discussion was published this year in 2021 in the Nature Partner Journals in partnership with the Parkinson's Foundation. And the paper is titled Non-invasive vagus nerve stimulation improves clinical and molecular biomarkers of Parkinson's disease in patients with freezing of gait.
Exactly.
Now, this was based on a project funded by the Department of Science and Technology, Government of India, under the Women Scientists Scheme A in 2018 as part of a fellowship that the first author, who is a DST women scientist, Ms. Banashri Mondal, did under the supervision of Dr. Hrishikesh. And a little bit about the WAS-A, or the Women Scientist Scheme, because I think it's brilliant. It is basically a scheme that's been evolved by the DST for providing opportunities to women scientists between the age group of 27 to 57 years, specifically for those women who are forced to take a break in their careers due to reasons like maternity, childbirth, and such. And that's because it was found that there were strict policies and age restrictions and qualification expectations that resulted in many of them being unable to do so. So it is quite encouraging and nice knowing that drawbacks in the system were identified and that women are being recognized and given such opportunities in the country. Would you like to share something about that, sir?
Yeah, I second that, Tripthi. What happens that there's no denying the fact that the female researcher, the women scientist, they come to a roadblock once they start their family, once they shift the career to the domestic responsibilities. And once they lag behind, then it's very difficult to get back to the mainstream. In that case, I would say this, we call it WOSA, WOSA of DST, that has done remarkably well, because I have one Bonoshi Mandal who got this, and she is the main person who carried the research, first author of this research, of this paper at least. And we have another lady, Dr. Rebecca Banerjee, who is postdoc, and she got it. So in my lab, two ladies have got it. And I can see that it has changed their career. There's no doubt about that. Moreover, when you see my lab, I have 11 fellows right now. Out of that, 6 are females, 6 are ladies. I would say that they are maybe better, or at least as good as anybody else. And the commitment they have, that's remarkable.
Brilliant, sir. That's so nice to hear. More power to women, I have to say that. Anyways, so first and foremost, sir, I'd like to hear, and I'm sure everybody would like to hear, a little bit about your gait lab and, Dr. Hrishikesh's famous gait lab and your interest in gait disorders and, any previous work on gait, really.
I must say that maybe 50% of my work is in gait area, and somehow wherever I am asked to speak, gait is one of the topic where I am asked to speak most frequently. Gait interest is there for a long time, and that was more concentrated in Dr. Jog's lab. Dr. Mandara Jog, I did my fellowship with him. And when you see his lab, there's very strong gait lab and very strong surface markers are there. So that created more interest. Moreover, I feel as a clinician, I would say that gait is one of the most important signs for clinical diagnosis. When the patient comes to your room, you know that what you have to look for and what you don't have to look for, right? Suppose the patient has Parkinson in gait. There's no point looking for a lot of things. There's no point looking for sensory system. Apart from disease, in health also, gait gives away so many things. Gait, when you see person's mood, not patient mood, mood is clearly reflected in gait. Confidence clearly reflected in gait. And in a sense that sometimes the race is also reflected. The way Indian people walk, the way the Western people walk, the way Chinese people walk, that's different. And that needs subtle eye to look for that. So gait is fascinating area that gives window to disease as well as health. So that created this interest. And gait lab is not cheap, it's expensive, but somehow I got some funding from institute to start with. And some of my friends came forward. One of the patient came forward to support this gait lab. And then some grants that then started up. When you come to India or any lab, grants, they don't start raining from the day one. You have to create some work. You have to create some papers. You have to create some pilot studies. Only then grants start coming. And those 4 5 years of support, I'm very grateful that I got that.
Right. So that's what I wanted to ask you. Like, before embarking on this seemingly difficult study, did you collect some pilot data?
Yeah, of course, yes. We had open level study of Parkinson's disease patient who had gait problem. We did VNS, pre and post VNS, a single shot VNS, and we found changes. But what happens when you see freezing of gait or gait abnormality in patients, it is so much placebo driven. So we are not very sure that this is placebo or this is really substantial. That was published in Movement Disorder Journal in 2019, but that was not enough to stamp that this is helpful. And that's why we embarked upon this double-blinded placebo control or sham controlled crossover trial.
And this whole idea of neuromodulation in Parkinson's disease and vagus nerve stimulation, where did that idea stem from?
Yeah, in that case, I would say that the ideas are littered everywhere. It's not, the original ideas are very less nowadays. Like, ideas are there, the puzzle, the piece of puzzle there everywhere. We all know that dopamine is not the only culprit, right, in Parkinson's disease. We know that cholinergic circuit is strongly supportive or strongly responsible for gait and cognition. We know that for a long time. Some papers are there. We know that vagal nerve stimulation is there that can stimulate cholinergic nerves, right? There have been one annual study about 5-6 years back when I went for a MD conference, Montessori conference. I found an annual study where they did invasive VNS in rat model, and they found some improvement in gait as well as some markers. Okay, I came back that let's do that, but invasive VNS doing in Parkinson's patient is very, very difficult. Meanwhile, I'm very lucky to have collaborators from Newcastle, and we keep on bouncing idea to each other. Stuart Baker and Mark Baker is in Newcastle. Stuart is basic scientist, Mark is clinical basic scientist. And when they came to Calcutta, they come to Calcutta almost every year and I go there. We bounced the idea, and I was surprised to know that they were also thinking in the same way. Vagal nerve stimulation in some motor and cognitive improvement of various diseases, not really Parkinson, but various diseases. And then we had few meetings, sometime in a bar, sometime in a restaurant, and in the yellow taxi of Calcutta, yellow taxi of Calcutta. And from there it started, right? And then we had advantage of having patient. Then we thought of vagal nerve stimulation in Parkinson's disease. The problem was that invasive vagal VNS is very difficult and very expensive also. So 6 lakhs for a patient. So we wanted to have non-invasive VNS, and there we lucked out because Mark Baker had access. Mark, my collaborator from Newcastle, he had access to non-invasive VNS, which was FDA approved at that time in migraine and epilepsy also, right? And Electrocore company is in the USA. He had access to that. He talked to those people. Bruce Simon is the vice president. I'm very thankful to him. And he supplied some instruments, which is free of cost to us. And that led to the study. So a lot of things had to come together to start this study.
Yeah, so it's nice that vagus nerve stimulation is essentially safe and non-invasive with the handheld device. And, with its anti-inflammatory effects, it's really worth looking into. Yeah. Like Dr. Hrishikesh said, double-blind, randomized controlled study with a crossover after one cycle of application. They looked at the efficacy of it as an adjunct therapy. And I also like the fact that you looked at the inflammatory markers and and more than that, the BDNF or the brain-derived neurotropic factor levels. So thereby looking at effect on neuroplasticity as well. So do you want to discuss? So basically,
we had some papers on BDNF and inflammatory markers in Parkinson's disease, not really VNS. And we found clear difference that inflammatory markers are upregulated in Parkinson's disease. The BDNF was downregulated in Parkinson's disease. So that data we had from our own lab and also from the lab of other people also. So we thought that we have that data, we have that know-how, and we had one wet lab also. So why not use that to see vagal VNS effect? Because nobody knows how it works, right? We can have conjecture that it works with vagal nerve, but after prolonged stimulation, whether it changes plasticity, whether it changes markers, nobody knew. So we thought that why not try that?
And your study was the first evidence of such so far.
Of course, yes, exactly.
Right. So, I mean, wow, for lack of a better word, wow. There is a flowchart in the paper showing the workflow. We could go into just some details. There were 36 patients that were enrolled at the start. 17 were to receive VNS, 19 sham controls. 3 withdrew at the start, and then the rest were assessed after a month. And then there was a washout period for a month. And, overall, there were about 8 dropouts. But, I think the dropouts were 2 from the VNS and 6 from the sham. So after that, there was a crossover, and then the sham group received the real VNS and vice versa. And in the second round, there were no dropouts. So can you tell us, discuss maybe the results in brief?
I'll add here. So when you call a patient in lab in India, especially, for one shot, it's fine. Patient will come. But teaching them to do VNS every day at home, 3 times a day, it was difficult, right? So it took a lot of learning curve for the patient and family members. And that is one reason we could not recruit a huge number of patients. At the same time, number of instruments were also limit because we got a limited number of instrument, but somehow it worked out. Regarding results, if you want, I can show 2-3 slides, and from there we can take it forward.
Sure.
So this is the paper published. Before I move forward, I can tell you that this is a reasonably high impact journal, and I'm very happy that the chief editor at that time was Dr. Kalol Ray Chaudhary. It's always a pleasure to when an Indian is sitting at him and he looks after or he filters your paper. It's always satisfying. This was what he talked about, that VNS and sham. 1 month washout and crossover. So everybody got the chance to get VNS or sham at least once, and it was double blinded. And sham and VNS, when you apply, I'll show you the instrument in a while, but when you apply, it feels exactly the same. The parameters are different so that the sham doesn't go inside the skin, it doesn't touch the vagus nerve, but it feels exactly the same. For the patient, it was sham was as good or as bad as VNS. So in gait world, especially in Parkinson's disease, velocity is very, very important. In fact, some of the recent paper, they suggest that velocity is the main parameter and everything depends upon that. So if you can show that velocity has improved by any measure, that helps that to show that your result is good enough and robust. So you can see that velocity improved, this percentage improvement, and the step length also improved. So these two are the parameters in Parkinson's disease gait. If you're able to improve that, that's wonderful, right? And both improved. At the same time, when you see the B, the stance time reduced. So that tells us that overall stance time is both feet are on the ground, that reduced. That means it's not only velocity, it's not only step length, the rhythm also improved. If stance time is more, that means you are lying on the ground for more time and your rhythm is broken at each step. But if stance time also improves, that means rhythm also improves. So this was the main result or main data from our study. We'll move on. UPDRS score 3. There was some improvement too, but not enough. But UPDRS 3, there was clear improvement, and that was statistically significant. Move on. So that was regarding gait parameter, clinical parameter. Then we came to this inflammatory markers, the TNF alpha. We can see that pre and post VNS, there was decrease in serum TNF alpha, and sham, there was no decrease. So when we see the two groups, there was clear decrease in inflammatory markers in VNS group and not in the sham group.
No.
Same way, reduced glutathione level, that is marker of oxidative stress, that also improved. And finally, one last slide, that BDNF, it was upregulated. BDNF is marker of neuroplasticity. So from this, when we see the last two, three slides, gait parameter improved, some gait parameter, not all. UPDRS improved, that was clinical. The inflammatory marker improved, that means inflammation was doing something. We don't know exactly what it was doing. BDNF improved, that's neuroplasticity also was favorably changed. So these 4 or 5 key result was there of my paper. I'll stop sharing now.
How do you feel these results extrapolate to a larger population, sir?
Yeah, first of all, this was a small study. So we have to take this with a pinch of salt, but it was double-blinded, and doing a double-blinded study, control study is very, very difficult, I can tell you. Open study is very easy, double-blinded, that means you have to diligent at many, many steps, and still we got some positive results. So I'm happy about that. How it extrapolates. So if we have a larger study, or if this is a clinically, we can use in clinical practice, it is very important. The reason is that gait is one factor, or freezing is one factor, which has no real good treatment, unless the freezing is dopamine responsive, right? If the freezing is dopamine non-responsive, then you are gone. Then nothing improves, be it dopamine, be it apomorphine, be it device, nothing informs. So if you have some tool to improve gait, which is dopamine non-responsive, that's great. And in that case, when you see the VNS, that is a small device, I'll show you as I told you. And if we can produce on mass scale, it will be very cheap. It's nothing. It is electrical stimulation. It is very cheap, and this can work as sort of demand pacemaking, demand stimulation. Whenever a patient has a bad day, when they are freezing, they can stimulate and it will improve. In short term, in long term, it can improve plasticity. It can improve inflammatory markers. So I believe that long term also it will improve. So it will have clinical implication in coming days. This is what I believe.
Now that you mentioned the dopamine responsiveness, that's what I was wondering what the on and off fog that we see. Did you have any patients like that falling under both categories, or?
Yeah. So, if I have to go back to do the study again, I would like to do off as well as on both. But to keep it simple, to keep it uniform, we did all the patients in off phase. Okay. But I agree that if we have to do it again, or if you have more resources, I'll do on freezing as well off freezing. Because when you have off patient, it's very uniform. On patient, because in on study, what happens that how much on the patient has on that day, very difficult. Because if the patient has good day, you have some patient that on dopamine they have very good day. And then that can cloud your judgment, cloud your result also. But off is little uniform. So that's why we did off at this point in time. But if I get another chance, I'll do on also.
And any other changes you would like to do besides this, if you got the chance to do it again, the study?
Yeah. So the result was good. But who knows that if we have customized stimulation, because we used the same stick for everybody, right? In DBS, think of DBS. Can you imagine having improvement with the same voltage, same parameter in everybody? No. Each person is different and each person needs different parameters. So who knows that if we have a new instrument, which we can easily make, and in fact, we are doing some work with some engineers, if we have an instrument that can be customized from outside for frequency, for pulse width, that we can customize from outside, and we can make a protocol that this degree of freezing, use this voltage. So who knows that I will have more positive response. At this point in time, we were very crude that we use the same parameters in everybody. So if I have to do it again, one, I told you on and off. Second, of course, larger number of patients, more instruments, cheaper instruments, India-made instruments, and instruments should have this customized for each patient, and that may work better.
Nice. And Dr. Hrishikesh, I know DBS patients are excluded, and do you see VNS being adapted for such patients in future? Yeah. As in, to people who are not responsive, or people who develop freezing of gait, and their heart difficult to control with DBS. Do you see this sort of helping them?
Both have different mechanism. DBS has different mechanism, if there is some mechanism known, and VNS is a different mechanism. It goes from periphery to the locus coeruleus to the cholinergic system. So I see clear room for coexistence of both the modality. Those patients who has done wonderfully on DBS, but after a few years' time they have gait issues, or those patients who has done wonderfully in bradykinesia, but gait has not improved, walking has not improved, cognition has not improved. This can be a good add-on to DBS. This is what I believe, and there is some evidence for that, because both have different circuits to work on. So I'm sure that it.
Right. And in terms of safety, there are no safety concerns with regards to this?
Yeah, so because VNS and this NVNS, non-invasive VNS, is being used in migraine, is being used in epilepsy, and FDA approved. So they have big data on safety of VNS in various populations, especially in elderly also. So safety concern, already we have data, and whatever we have done two study on that. One was open label study, and another was this crossover trial. And in none of the patients, we had any problem regarding safety. We knew that this can affect cardiac rhythm. So we did ECG, we checked pulse rate continuously. We did ECG pre and post also. And there was no untoward incidents in any of the patient. So safety-wise, it seems to be pretty safe apparatus.
That's good to know. So a pressing question: how feasible will this therapy be, especially in our Indian population, with regards to cost effectiveness and such?
At this point in time, if you have to import the instrument, it won't be feasible at all, because we got it free, small number, but I'm sure that it's hundreds of dollars for per annum. And second thing is that till now, whatever instrument we have, it has inbuilt battery, and if battery is gone, it's gone, right? But I'm repeating that again. When you open the instrument, which I have not done that, but when you open this instrument, it is nothing. It is just electric stimulation. NVNS, which is electrocore company, gamma core is named. So you can see that there nothing but two electrode, right? It has some parameters written here. You press it, okay? You put it here, and you press it, and it starts giving small little current, and that's it. So there's a protocol for migraine, protocol for seizure. For this, we did 2 minutes, 2 times, and 3 doses. So this instrument has nothing but stimulation. So it's once that they allow to make it locally in India, and I don't think that one instrument will cost more than 500 rupees if it is made.
Wow.
So,
yes. Yeah, that would be incredible.
And you can easily put rechargeable battery. But of course, this is from a company, and it's under patent law right now. So right now we cannot do that. But in due course, I can see that light.
Do you see its future in managing other non-motor symptoms, in Parkinson's disease? Because your study did mention that you didn't see any clear benefits in cognition in RBD or REM sleep behavioral disorder.
One disappointment, I would say, with the result in the study was no improvement in non-motor functions, non-motor scale, because considering motor system, depends on dopamine as well as cholinergic system. But non-motor is predominantly cholinergic or non-dopaminergic. So I expected some improvement in that, which has not happened. So that tells us that the tailored approach, what I talked about, that may help. That tells us that it may need longer stimulation. We did only for 1 month, longer stimulation. But when we see the mechanism, I can see that this should work, and we'll try again for longer time in the bigger populations. So I see light there. I see that this should improve that.
So what is the future focus, sir? What are the future plans? Do you have future plans in further extending this project?
Yeah, of course, yes. So we are in talk with Electrocore to have more instruments. And as I told you, Bruce Simon is a vice president and is very supportive of that. And we have collaborators, Stuart Baker and Mark Baker from Newcastle. They are also trying to connect with them and help us. So focus will be two-pronged. First of all, to extend this study so that we have more data. We have data from non-motor also. And also to look into dyskinesia, because when you see Parkinson's disease, three things I would say. It is quite difficult for clinician. One is freezing or gait problem. Second is non-motor problem, not much treatment in majority of cases. And third is dyskinesia. So, and dyskinesia, when you see the basic science study, the mechanism also involves locus coeruleus, also involves cholinergic system. So there can be a hypothesis that dyskinesia, this can help. Levodopa-induced dyskinesia, and if it helps, that is a wonderful thing. That you can keep on giving levodopa and keep on doing this, so that gait improves, cognition improves, and dyskinesia improves. So this kind of wonderful adjunct to that. So this is the hypothesis, and I'm looking forward to extend that. Unfortunately, we got a IAN grant last year. That was inaugural grant of IAN research grant. And very happy that I shared this grant with Arushi from PGI, who is a wonderful clinician and researcher. So we got the grant, and one of my research fellow, I've given this as a PhD project, and we started in that. So I can see that some role in dyskinesia also. So two ways: one, to extend whatever we have done, and second, to add dyskinesia, levodopa-induced dyskinesia, as one of the substrate.
And that's what I wanted to ask you about. So the levodopa-induced dyskinesia project, that we're all excited to see the turnout of that for sure.
And most important will be to develop an indigenous, very cheap, non-invasive VNS. So that is the third project, which I alone cannot do that. My clinicians cannot do that. I need help of engineers, researchers, and we are looking forward to that.
Right. So this project alone, do you think the MDSI could perhaps push for a collaborative research team across centers, that we could have a larger randomized control study?
Yeah, the whole premise of MDSI is not only doing conference for education and also for collaboration. So I can say that there is clear role of MDSI in making it widespread, to involve more and more centers. Once we have enough instruments to have a more uniform study, maybe 500 patients, maybe 400 patients, and if you have that data, this is a gold mine, isn't it? So I can see the role of MDSI in that, and being office bearer of MDSI, and a lot of like-minded people are there. We will push forward for it.
Absolutely, sir. So we've discussed about the study, but before we conclude, because this is a whole, you're the secretary of MDSI, and this whole initiative is a part of MDSI. So what does the MDSI have? What are the plans for the future in terms of research, in terms of developing movement disorders across the country? You've been very encouraging to, especially as youngsters, and there's a lot of work that's been happening lately. But could you share a little bit just for our listeners? And
yeah, Tripthi, you have seen the scenario of MD movement disorder in India, and I can tell you that it is the most exciting branch to be at this point in time, in India at least, right? The way it is growing in last 6 years, 7 years, the way MD movement disorders has taken the minds of youngsters, it's unparalleled as compared to any other subspecialty. And I'm lucky to be part of MDSI at this point in time. When you ask me that how I look forward to help grow MDSI with all my colleagues, my seniors who started this, I would say that most important thing is the inclusiveness, to include more and more youngsters, to include more and more even DM students. And that's the reason we started this MDSI-Vaani. That's the reason we started this JQ, Journal Quest, and a lot of things are going on. So personally, I feel that the effort as well as credit should be shared by everybody. And without that, no society will grow. If only small number of people who think that they will grow, that's not going to happen. Apart from that, education is very important, and we should try to improve education at all levels. It's not only genetics, it's right from the beginning. What is Parkinson's disease for MBBS also, right? So I look forward to improve education right from the MBBS to the most advanced level with whatever way it's possible. And finally, collaboration is very important. We are very, very, very poor in collaboration, no doubt about that. But last 4 years, when you see, the scenario has changed. A lot of studies we are doing multicentric. The genetic study taken by Prashant, the PRAI taken by Dr. Rupam, who is present right now, Dr. Pramod Pal coming forward with RMD, rare movement disorder. So things are gelling, things are coming together. Without collaboration, it's not going to help. We should keep in mind that unless we have enough papers, enough publication, we won't get value at the global platform, and we are moving towards that. I also feel that as a basic scientist, somehow we are ill-trained as a clinician, we are ill-trained in the basic science. That's not going to work. Each clinician should read basic science, should do work in basic science. Unless you understand that, you cannot advance the science. And that's why the thrust of my lab is mainly basic science as well as some clinical work. But when you see all my 11 fellows, they are from basic science background, except one. So these are the few things I'm looking forward to forward in next 2-3 years.
It's definitely amazing, sir. And I always like to say that I feel like movement disorders is the most vast subspecialty in neurology, and most exciting as well. And we're so fortunate to have yourself and other stalwarts in the field, and you've really pushed leaps and bounds in the past few years. So it's really amazing to see the growth in our country. So with that, we come to the end of this interview.
But may I say thank you to those people who helped in the paper. So it's very important to give credit to those. Monashi Mandal, of course, because she took over the study and she did all the groundwork. And Electrocore, we talked about Electrocore and Bruce Simon. My collaborators, especially these two guys, Stuart Baker and Mark Baker. We also got some help from some feedback from Lynn Rochester, who is well-known gait researcher in Newcastle. So these are people who inspire us. And then everybody in my team, Supriya Chaudhary is there, who is assistant director, and he helps me in all the project. And all the members of my team, they have evolved into such a dedicated worker it's amazing. You come someday here and you'll find that it's great to be part of that bunch rather than other way around. It's great to be part of that bunch. Of course, patient. And as I told initially that without help of hospital administration, which I'm part of that now, without initial help, it won't work. When the hospital's focus is to earn only money and no value in research, it's not going to work. So I'm fortunate to get the best of both the world, this private practice as well as the research. So these are people and patients, of course, because Parkinson's is a disease. When you come back to that in 5-6 years time, they will become your family. Patients will become your family. Then whatever you do, whatever you ask to do, they are there. And that's amazing strength what we have in India.
Right. Yeah, and the thrilling aspect of this, the vagus nerve stimulation, lies in its potential to be a biomarker for Parkinson's disease, right? With even neuroprotective benefits. So, and just with a simple handheld device. So it would be great to see more work in this area. And congratulations to the team and yourself on jumpstarting research in this very promising area. Thank you so much once again, sir. You continue to be an inspiration for all of us, not just as a clinician and researcher, but also as a true leader in the field. And I cannot wait to see the turnout of all your ongoing projects. So with this, we conclude today's episode, and we will be back again soon with the next one. Thank you all once again for tuning in, either through our audio series or the YouTube series videos. And we hope you all are enjoying these podcasts and, more importantly, learning and being inspired. I am Dr. Tripthi Sugumar, and from MDSI, signing off now. Cheers.
Thank you, Tripthi. It was amazing talking to you, and it was absolutely my pleasure. Thank you very much.
Thank you, sir. Thank you so much.
Yeah, thank you, everybody.